The sound barrier has been shattered, ladies and gentlemen, but the race for the stratosphere has only just begun. We have conquered the speed of sound with our fighters, and now the great commercial empires of the world turn their eyes toward a new prize, the supersonic transport. The British and French are welding together their Concorde, and the Soviets are hammering out the Tupolev. But the United States of America demands a machine that will dwarf them both in size, speed, and sheer audacity. Enter the Boeing 2707. This is not merely an airplane. It is a titanium leviathan designed to carry 300 souls at nearly 3 times the speed of sound. While the military has proven that sustained Mach 3 flight is possible with the exotic XB-70 Valkyrie and the shadowy SR-71 Blackbird, bringing that power to the ticket-buying public is an engineering challenge of Herculean proportions. The skin friction alone at Mach 2.7 generates enough heat to melt standard aluminum, requiring the entire airframe to be forged from stubborn, expensive titanium. Boeing's vision is radical. To solve the problem of landing a supersonic dart on a subsonic runway, they have turned to the swing wing, variable geometry. Massive hinges the size of automobile axles are designed to sweep the wings forward for takeoff and tuck them back against the tail for the dash across the Atlantic. It is a design of breathtaking complexity. Imagine a structure as large as a 747 changing its shape in midair while outrunning a rifle bullet. But the laws of physics are cruel masters. The weight of these massive pivots is threatening to ground the project before the first rivet is driven. The engineers are fighting a war against ounces, stripping away amenities, battling the square cube law that dictates a larger plane becomes exponentially heavier. We are witnessing a gamble of national prestige, a billion-dollar poker game where the stakes are the future of human travel. Will the 2707 shrink the globe, or will it become the most expensive museum piece never to leave the ground?
During the summer of 1963, President John F. Kennedy unveiled a significant new aviation initiative.
There was strong faith in the future.
He challenged America to develop and operate a supersonic jet capable of cruising beyond 3,000 kilometers per hour.
Program in civilian aviation. Supersonic flight.
This narrates the tale of Kennedy's vision, a machine at the absolute frontier of engineering. A craft intended to soar quicker and loftier than all competitors, the Boeing 2707. Among John Kennedy's inspirations was John Glenn, the initial American to orbit Earth. Yet Glenn was also the pioneer who crossed the American continent at supersonic velocity back in 1957. From that moment on, Kennedy had envisioned creating an American supersonic passenger transport. Different nations shared that ambition.
The British began their supersonic aircraft program in 1943, midway through the war. It was a design, obviously, at that stage, which called for an aircraft to be capable of Mach 1.5. That's 1.5 times the speed of sound, or about 1,000 miles an hour, which is really quite adventurous when you think about the speeds they were achieving in those days.
The British pursued various concepts. Notable examples included the Miles M52 and the de Havilland DH-108 Swallow. However, Britain lost the ultimate race to Chuck Yeager, piloting the American Bell X-1.
To tell you the truth, I was hopping mad, because I realized we could have done it and we'd missed the boat by a cancellation. Not with the DH-108, but with the Miles M52. I was to be the pilot of the Miles M52, so I'd followed this carefully, and we were 80% ready for the first flight, when, without any warning, without any consultation, the aircraft was cancelled.
On October 14, 1947, the rocket-driven Bell X-1 stood as the first plane to exceed the speed of sound.
The British were really upset that the Americans had been first through the sound barrier, because British technology was ahead of the Americans. The British just fluffed it, lacked the guts to do it.
The explanation the British offered for halting the Miles 52 was insufficient data regarding the physics and airframe encounters near the sonic wall.
When an aircraft approaches the speed of sound, several things happen. The most disturbing of which for the occupants of the aircraft is the aircraft begins to shake and rumble, depending on how rapidly or how slowly you approach the speed of sound. But in aerodynamic terms, a wave builds up, an area of compressibility builds up, a shock wave. And what that does is that causes increased drag and increased heating on the aircraft, such that as you approach the speed of sound, as the shock wave passes over the flying surfaces, what that does, it causes the wings to lose lift both above and below the wing. And that has a downward effect on the aircraft. So the aircraft will start to dive if you don't do anything else about it.
A technique for managing this involved utilizing hydraulic control surfaces, specifically the tail's elevators. During subsonic travel, air passes over the airfoil smoothly to generate lift. But in the transonic phase, a shock wave develops which produces significant drag. At sonic speeds, this wave rests on the wing, exerting a strong downward force. Hydraulic flight controls remedy this by pushing the aircraft's nose upward.
You'll first start to notice the problem of approaching the transonic area, approaching the speed of sound from about 0.9, so 9/10 of the speed of sound at sea level. And there you'll begin to experience a buffet as the shock wave begins to build up. And as you approach the speed of sound, the closer you get to the speed of sound, the greater that buffet will be, until that moment when you pop through the other side and that shock wave is then traveling behind the aircraft. You then punch through into an area of far more stable air, an area of almost quietness, if you like.
By the mid-1950s, combat jets were frequently breaking the sound barrier, though only for brief intervals. Maintaining supersonic cruise proved a far greater hurdle than simply piercing through the sound barrier once.
Supersonic flight for passengers is actually very different from supersonic flight in the military context. If you're going to fly passengers at supersonic speed, you have to fly them for a long, long time at high speed, whereas military operations tend to be a quick dash.
Just one nation chose to confront this difficulty. Having lost the initial sonic race, the British then began the creation and refinement of a supersonic passenger liner. This marked the beginning of a competition that would fundamentally reshape the landscape of global flight. On March 10, 1956, Britain reasserted its dominance in the high-speed arena when the experimental Fairey Delta II shattered the world absolute speed record, reaching 1,820 kilometers per hour. The Fairey Delta II debuted several groundbreaking innovations. It featured a slender delta wing, ideal for sustained supersonic cruising, and a tilting droop nose to provide pilots with necessary visibility during takeoff and touchdown. Encouraged by this achievement, the British formed a dedicated committee to oversee the creation of a supersonic passenger jet.
The most interesting aspect of the Fairey Delta II that we see on today's Concorde was the drooping nose. Now what that is it's simply, as you see in Concorde, a nose that kinks. One of the problems with the delta-winged aircraft, and an aircraft that is designed for going supersonic speeds, is that in order to fly very fast, obviously you need something that is as aerodynamic as possible. The problem is they are very, very difficult to fly at low speeds. So when they come into land, they have a very high angle of attack, and very, very difficult then for the pilots to see what they're doing. So they then put this kink in the nose, if you like, to have this cantilevered nose, such that in takeoff and landing, to give the pilots better visibility, they put this design feature in, which we see today.
By March 1959, initial engineering had matured enough for the Supersonic Transport Committee to finalize its primary strategic proposals.
There were two main recommendations. The first was for a small, fairly simple aircraft to carry around 100 passengers and do about Mach 1.2. The second design was for a 150-seater that should have been capable of Mach 1.8, which was considerably bigger and considerably faster.
By 1959, the British thinking had crystallized into two projects. A medium-range supersonic airliner, which had a rather crazy M-shaped wing, very difficult to build. And the other project was the classic, what's now the classic long, thin delta for a supersonic airliner that could fly across the Atlantic.
This led to a pivotal resolution that would determine the trajectory of the international race for supersonic travel.
When they awarded the design study contract in 1960, the British made it a condition to BAC, who got the contract, that they should seek international collaboration for the building of the supersonic transporter.
Initially, the British Aircraft Corporation reached out to the United States, but in 1960, American officials showed minimal desire for a joint venture. Consequently, the British looked toward France as a prospective partner.
The British and French eventually decided to cooperate because the supersonic airliner project was just too big for either of them to do on their own. It was helped by the fact that the two different design teams in France and in England had more or less come to the same conclusion about what the aircraft should look like.
The resulting aircraft utilized a refined delta wing configuration. It was named Concorde, a term shared by both nations, signifying unity and collaboration. However, to gain international legitimacy, Concorde required commitments from major carriers. In June 1963, the project secured the vital contract that guaranteed its production. Remarkably, this order originated not in Europe, but from Pan Am, the preeminent American airline of the era.
Pan Am was such a good customer that they could go in and play one aircraft factory leader against another. And Tripp didn't mind going in threatening and saying, look, if you don't do this, I'm going to get somebody else to do it. And if I have to go to Europe, I'm going to Europe. Tripp was an overpowering figure in the industry at that time.
Pan American Airways had launched its legacy on October 28, 1927, completing the first scheduled international route by a U.S. carrier. A Fokker trimotor carrying mail departed Key West, Florida, arriving 70 minutes later in Havana, Cuba, covering a 135-kilometer span. Pan Am's 28-year-old visionary founder was the famed Juan Terry Tripp. It was Tripp's innovative insight that mail-carrying aircraft could seamlessly double as passenger transports. By installing seating in the cabins, he offered the Havana route for a fare of $100. Tripp was obsessed with ensuring Pan Am remained the dominant force in American aviation.
In the post-war world, in the 1960s, Pan American Airlines was one of the big names. Most American airlines tended to fly inside America, but Pan Am had built his reputation on flying all around the world. And they did that by always buying the latest and best aircraft.
On October 26, 1958, his airline became the first in the US to deploy a commercial jetliner, the Boeing 707, named Clipper America. It serviced the New York to Paris route, cutting previous travel times by 50%. Juan Tripp was equally committed to making Pan Am the first carrier to enter the supersonic age.
If you joined Pan Am as a pilot in the late 1950s or 1960s, the first thing they told you was, you hang in there, guys, because you are going to fly supersonic. Pan Am saw that being the first to be with the supersonic airliner as you know, the thing that would brand the company as the place to go.
Yet, this bold move by Pan Am was about to ignite a massive American counter-response. Just days following the June 5, 1963 announcement, President John F. Kennedy declared his administration's commitment to backing the American aviation sector in creating a supersonic transport for domestic carriers like Pan Am to operate.
When Kennedy heard that Pan American were going to buy the European Concorde. He was apoplectic. He was furious. And he phones up head of Pan Am, one Tripp, and just gives him a bawling out. And Tripp says, well, the alternative is you give me an American supersonic airliner. So from that moment on, Kennedy decides he is going to get a hold of the American aircraft companies and he's going to make them build a supersonic airliner faster and higher in performance than the European rival.
Thus, the competition was ignited.
The immediate result of Kennedy's intervention in the race to build a supersonic transporter was the appropriation of $100 million worth of funding from Congress, which in 1963 was a serious amount of money.
Concorde finally faced a US competitor. The pressing mystery was which firm would take the lead. An anticipated contender was Douglas, the premier manufacturer of commercial planes, ranging from the legendary DC-3 to the jet-powered DC-8. However, Douglas lacked the necessary capital to enter the fray. Other prospects included North American, then developing the massive B-70 Valkyrie supersonic bomber, and Lockheed, which possessed extensive expertise in high-speed flight through the classified SR-71 Blackbird program. There was also Boeing, the architect of the formidable B-52 bomber and the successful 707 jetliner family.
Of all the American aircraft companies, paradoxically, Boeing was the one that had the most trouble in getting into the supersonic airline business. Boeing hadn't actually delivered a supersonic aircraft to anybody.
In the present day, Boeing stands as a global titan in the aerospace industry. The corporation maintains a massive workforce and provides services to clients across nearly every continent. It historically established a benchmark with revenues reaching toward the $60 billion mark. Yet, Boeing originated from very modest roots. The founder, William Boeing, was the child of a prosperous timber merchant. In 1903, he left Yale University for Washington State to seek his own wealth in the lumber trade. In 1910, William Boeing traveled to Los Angeles for the inaugural American Air Meet. He sought a flight in one of the aircraft, but not a single pilot among the dozen present would agree to take him up. Boeing returned to Seattle with the resolve to construct and pilot his own machines.
Bill Boeing was, some people think he was an inventor, but Bill Boeing was an innovator of the highest order. I think he has very few patents, perhaps if any, but he would look at a product and he could see where he could make it better.
On July 15, 1916, he established his aircraft manufacturing company in an old Seattle boathouse. He recruited shipwrights, whose woodworking precision was perfectly suited for early aviation construction. The fledgling Boeing firm flourished by producing seaplanes for the Navy and fighters for the Army. But it was the Second World War that propelled the company to its zenith.
The war was starting in Europe, and Wright Field put out an order for bids. At this time, most of the airplanes were two-engine. We were still two-engine. Douglas was doing a two-engine bomber, and another company was doing a two-engine bomber. And Boeing went in to Wright Field and said, would this procurement cover a four-engine bomber? And everybody just went berserk because nobody ever conceived of a four-engine bomber.
This was the XB-15, a four-engine prototype boasting a 45-meter wingspan.
It was so big, you could tunnel out through the wing, and you could come into the nacelle, and you could make repairs in flight.
A scaled-down variant of this Titan would achieve immortality. The B-17 Flying Fortress, which dominated the heavens during the war years.
I think they ordered 13 or 14 what they call test airplanes, and that led to the Flying Fortress. I don't remember exactly how many were built, but it was around 13,000. And that airplane then went through the A series, B series, C series, all the way to H, as I recall. I'd say the story of the B-17 was it was such a versatile airplane, was able to keep carrying more bombs, more turrets.
As men deployed to the front lines, women stepped in to manufacture the aircraft. Thousands of female workers filled the labor void, driving Boeing's output from 60 units monthly in 1942 to a staggering 362 planes per month by March 1944. The B-17 was succeeded in 1942 by the B-29 Superfortress. In Wichita, laborers, homemakers and merchants assembled B-29s during grueling 10-hour shifts, a period famously dubbed the Battle of Kansas.
World War II transformed the fortunes of the Boeing company. Before that, it was a serious manufacturer, but planes were built in small numbers. World War II meant Boeing was producing vast numbers of giant bombers on huge assembly lines.
Following the war came the B-47, the first jet-powered bomber in the U.S. arsenal. And on April 15, 1952, test pilot Tex Johnston conducted the maiden flight of the B-52, a strategic bomber that would remain a cornerstone of aerial power well into the 21st century. Then, Boeing decided to take a massive risk.
In the 1950s, Boeing was doing quite well in military contracts for the B-47 and the B-52 bombers. But no aircraft company, can afford not to look ahead because it takes a long while to develop aircraft. And so they took a bold decision. They decided, well, let's take some of the profits from the bombers, some of that technology, and see if we could mix that into an aircraft that passengers would want to use, that the airlines would want to buy.
We had all the knowledge of the B-47, the B-52, so it wasn't too big a job in the wind tunnel to develop a low-wing airplane that could be used as a tanker, and we knew they needed a tanker, so there had to be a tanker, and we hoped it could be a passenger airplane, although we weren't really sure that that was the case. So that's why the Dash 80 was born.
The Dash 80 ascended into the skies guided by Tex Johnston, the same pilot who had mastered the B-52. Determined to prove that Boeing had engineered a superior aircraft, Johnston performed a barrel roll with the Dash 80 over Lake Washington's Seafair hydroplane course on August 7, 1955. A daring stunt typically reserved for agile fighter jets. Boeing's president, William Allen, watched from below as his company's future hung in the balance.
And Allen turned completely white, looked over at his technical advisor, Wellwood Beale, and he said, "Did we authorize that?" And then just before he could turn around, here he came back again and did it once more.
The gamble was a resounding success. The Dash 80 served as the foundation for the KC-135, the world's first jet-powered aerial tanker, which subsequently evolved into the Model 707, the progenitor of Boeing's legendary lineage of commercial jetliners. Boeing's strategy with the 707 was ingenious. Consuming roughly 1/10 of the fuel, a 5,707 could transport as many annual transatlantic travelers as the 30 million Queen Mary ocean liner. In one stroke, Boeing had birthed a new market and signaled the end of the grand passenger ship era. By 1958, as the 707 began its tenure with Pan Am, Boeing established a specialized team focused exclusively on the development of a supersonic passenger jet. By 1960, the firm was investing more than $1 million each year into the initiative. The concept was labeled the Boeing Model 733.
Boeing actually started work on supersonic passenger airliners very early on, right at the beginning of the 1950s. But in a kind of research way, is this possible? Where are the engines going? Where is the metallurgy going? But what you begin to see is by the end of the 1950s, they're starting to get quite serious about it. They're beginning to think this can be done.
Following Kennedy's directive for the United States to construct an SST, the Model 733 finally stood on the verge of becoming a reality. Through the end of 1963, the three main rivals for the American SST contract, Boeing, Lockheed, and North American, refined their blueprints in total secrecy. The industry waited to see who would prevail and what form the aircraft would take. More critically, observers wondered if a late-starting American entry could still seize the global market. By the close of 1963, fabrication of the first Concorde components was already underway in Europe. Could the United States close the gap? A historical precedent suggested it was possible. The British Comet had been the pioneering jetliner of the 1950s, but a sequence of tragic accidents exposed catastrophic design weaknesses caused by rushing the plane into service to outperform the Americans. Consequently, the Boeing 707 emerged from the shadows to dominate the airways throughout the mid-20th century.
The Americans came late to the supersonic race. They wanted to leapfrog the Europeans, and so they decided to go faster. The Europeans were going for Mach 2.2, which meant they could build Concorde out of existing materials using existing technology. The Americans decided to go way up to Mach 3 through the so-called heat barrier, which meant that because of the stresses on the plane at those speeds and the heat that would build up on the fuselage, they had to use new materials. So the Americans were going for a technological breakthrough to try and get ahead of the Europeans and bury the competition.
To eclipse both domestic rivals and the European Concorde, Boeing envisioned a craft significantly larger than its competitors, designated the 2707.
Boeing realised that if they were going to beat the Anglo-French Concorde, they would have to be bigger, better and faster. So their design was for a faster aircraft and for one that would carry 2.5 times the number of passengers as Concorde. So instead of 120, we're looking at 277 passengers on board.
To facilitate the engineering of the 2707, Boeing constructed a massive full-scale mock-up. The airframe spanned 93 meters in length, making it roughly 1/3 larger than the Concorde. It was designed to accommodate 277 passengers, 30 in first class and 247 in coach. This capacity was 2.5 times greater than what the more compact Concorde could offer. The interior configuration was a radical departure from the past. Until that point, cabin layouts consisted of narrow seating flanking a single aisle, which often created a claustrophobic environment for travelers.
Boeing decided that in order to entice people into this new aircraft with these fancy speeds, they'd have to offer a bit of something else. And so they made the fuselage bigger so they could get more seating in. Today we are very used to three sets of seats, 2 aisles. But this was the first time when Boeing was developing the supersonic airliner that they decided to introduce that into an aircraft.
In contrast, the Concorde featured a very slender fuselage and the traditional 2-abreast single-aisle configuration. The 2707 was intended to be propelled by 4 massive turbojets, each engineered to produce nearly 30,000 kilograms of thrust. During takeoff, the combined power would rival the output of several dozen heavy locomotives.
The Boeing 2707 had 2 other very interesting features. The first was a drooping nose, not unlike we see on Concorde today, to allow the pilots much better visibility in takeoff and landing, and then to be flicked up for that needle-like high-speed flight. The second design feature was also to do with the differences between low speeds for approach and landing and high speeds in supersonic, and that was the swing wing. The wing was able to pivot for those slow speed areas, making it easier and safer to fly when taking off and landing. But then when it was up above the Atlantic or Pacific or wherever it was going to go and approaching its speeds of Mach 2, you could sweep the wings back and get a very similar effect to the Delta.
The wings on the Boeing 2707 prototype mock-up were designed to sweep manually, shifting from a fully retracted 72-degree angle for high-speed cruise to a 30-degree extension for stability during takeoff and landing.
The Boeing supersonic airliner was really pushing the boundaries of aviation technology. They were going to go faster, they were going to go faster for longer, which meant new materials, new kinds of engines, new kinds of avionics. It was a risk.
Lockheed, a major competitor, remained skeptical of this complex swing-wing design while finalizing its own entry, the Lockheed L2000.
The Lockheed design for a supersonic airliner was simple, elegant, beautiful. no complex moving parts like a swing wing. They'd adopted the narrow delta that everyone knew was going to work. It was within the boundaries of what was possible. They were minimizing the risks, and that's why it was a serious competitor.
As the deadline for final design submissions approached, Boeing continued its ambitious strategy to overshadow all rivals.
As the design process went on, it became obvious that the Boeing entry was going to be terribly complex, terribly expensive. That made the airlines who were going to have to buy and use the thing frightened. So Boeing started adding on more and more passengers in the hope that it could make a profit that would make up for the escalating costs of the aircraft in the first place.
Size does help you a little bit on efficiency, at least it has on the other airplanes, and so obviously you can go overboard and be too fast, but too big. But I think that we felt the Concorde was too small to be a successful system.
On the final day of 1966, the winning design was officially declared. The revolutionary Boeing proposal had secured the contract.
I think it was a very tough competition. The reason we won the configuration was not necessarily that the airlines liked our configuration any better. My personal opinion is that I think that they felt that they would rather have Boeing build their commercial airplane than the other two manufacturers, because we were in the process of building commercial airplanes at that time and working with the airlines, and my personal opinion is that we were picked as a company, not as a design.
It was a surprise that Boeing won, because they had so little experience in building working supersonic aircraft. I mean, they were famous for the B-52 bomber, which is subsonic. Everyone else, I mean, Convair, Lockheed had built large and fairly successful supersonic aircraft. So this was the new guy on the block suddenly being given the job, and everyone thought, can they do it?
Boeing's leadership forecasted that if prototype construction commenced in early 1967, a maiden flight would occur by 1970. They projected that the first aircraft would enter commercial service by mid-1974. In retrospect, these timelines were entirely unrealistic.
The main problem in designing the Boeing supersonic airliner can be summed up in one word: the weight. This thing just got fat. It got heavier and heavier. It wasn't going to make money. They had to then strip out weight, and in the end, the biggest weight penalty was going to be the mechanism to make the wings swing.
As we got beyond the preliminary design stage to build it, the weight got too heavy. The empty weight got too heavy. That was the main problem. The weight just got out of hand, and we couldn't meet the weight statement that we'd estimated for the configuration at the start.
The program ground to a standstill for an entire year as Boeing explored alternative configurations. By October 1968, the company presented a version that was essentially a total redesign.
There was only one way to solve the weight penalty problem. That was to take the swing wing out.
Boeing's swing wing disappeared mostly because of the extra weight. That huge hinge in there was very, very heavy.
The revised 2707 was smaller, with seating capacity dropped to 234 passengers, though it still remained larger than the Concorde. However, a new crisis emerged that would plague the project and ultimately lead to its demise: the sonic boom.
We knew it existed, but frankly, I didn't think it was that bad. The sonic boom that the airplanes we were talking about was like thunder and lightning, where the thunder hits about 2 miles away. And I guess I just didn't figure it was that bad.
In order to explore the effects of the sonic boom on, for example, urban areas, the American Air Force conducted an experiment in 1964, which is something I don't think we would ever contemplate doing today. And what they wanted to do was see what effect it had on an urban area. So they they flew supersonic bombers over Oklahoma City with sonic booms or waves of shocked air passing all the time. the result was that in a very short period of time, they had around 8,000 very vocal complaints and around 5,000 complaints for claims for damages.
In 1967, following Boeing's selection, Harvard scientist Dr. William Shercliffe founded the Citizens League Against the Sonic Boom.
Well, actually, there were so many technical and economic hurdles that had to be addressed for an airplane like this, not the least of which was the sound. Breaching the sound barrier always created shockwave over populated areas.
Well, that era was a miserable era for me, because here I was, an engineer trying to do things, and you had these idiots back there making. It was a political situation, and he just jumped on it. This guy Shercliffe, I never met him. I don't know what his problem was. I know the British were taken by surprise on it. They were completely amazed at the problems we were getting.
Other researchers theorized that SST exhaust released in the stratosphere could trigger a self-sustaining chemical reaction. They warned this would deplete the ozone layer, reducing its ability to absorb radiation and potentially leading to a rise in skin cancer cases.
I think there were other environmental concerns, perhaps not substantiated technically, about the ozone layer, about contamination of the upper atmosphere. There were all sorts of boogeymen shoved into the front of the table having to do with so-called environmental problems.
Public sentiment shifted sharply against the project, and as opposition mounted, Congress began to voice serious reservations about the aircraft's viability. In response, President Richard Nixon, shortly after his 1968 election, formed a 12-member committee to evaluate the program's future.
Nixon was a firm believer in the SST when he came to power, like Presidents Johnson and Kennedy before him, and he felt that the SST was essential to American prestige. And in order to underline the case for the SST, he appointed a committee. To his great surprise, I think, and consternation, the committee came out against the SST and decided it was completely unviable.
Beyond the environmental concerns, the Boeing SST was struggling with performance goals. When President Kennedy first established the program's objectives, he had mandated that the American transport must surpass its European competitor by reaching a speed of Mach 3. Yet at such velocities, an aircraft's exterior becomes incandescent. Engineers must utilize exorbitant materials capable of enduring these temperatures without warping or fracturing.
To reach the speed that the 2707 was going to go at, you had to find new materials to deal with the buildup of heat. The most effective material would be titanium. And at that time, titanium was really, really complex to machine, very expensive to get a hold of. It was going to make the whole project uncommercial.
It's tough environment, and temperatures of Maine is a real big problem. And whether you can ever design a structure to meet all this and still have enough left over to make any money with is not too clear at this point.
The British had concluded long ago that these thermal hurdles were too complex and costly to overcome. Concorde was designed to cruise below 2,000 kilometers per hour, significantly mitigating the friction-induced heat. This allowed the Concorde to be constructed from conventional aluminium alloys, keeping production expenses manageable.
You went much faster than Mach 2. We got too hot for aluminum. I don't know, aluminum, I can't tell you exactly, but you wouldn't want to go too much beyond 2 to get to with aluminum, so you needed a better material. And titanium was quite capable. It was a good material, and we felt that it would be. So part of the program was learning how to manufacture.
As Boeing specialists struggled with these obstacles, the 2707 initiative faced relentless setbacks while expenditures surged.
We spent several $1 million of our own company money in working titanium on the side of the outside of the contract on the SST, but maybe we were too ambitious. It might have worked at 2.5 Mach number, but I think that you go 3 and that's 400 degrees, and that's too hot.
On May 18th, 1971, the United States Senate convened to vote on terminating the SST project's funding. Despite President Nixon's intense lobbying to sustain the program, his efforts failed. By a vote of 58 to 37, the Senate effectively ended the life of the Boeing 2707.
I think that Kennedy's decree that the SST should be bigger, better and faster than the European rival did cause major problems for Boeing and for the whole project right throughout it, because they were always aiming for this kind of Kennedy standard of Mach 3 and all the problems that are associated with flying at Mach 3.
I think that was too hard. It just wasn't practical. I think we could go faster than the 2. I think 2.5 would have probably been okay from a temperature standpoint, but certainly any higher than that would have probably not been practical.
Europe appeared to have claimed the technological crown. In 1973, just 18 months after the American project was dismantled, Concorde touched down in the USA for the opening of the new Dallas-Fort Worth airport. During its 4-day Texas residency, it performed supersonic exhibitions over the Gulf of Mexico, becoming the centerpiece of the airport's dedication ceremonies. However, it soon became evident that Concorde's triumph was hollow. The same issues that doomed the 2707, most notably the sonic boom, now hampered the European jet. British Airways launched its inaugural supersonic route between London and Bahrain on January 21, 1976. Because the path was largely over land, the aircraft was forced to fly at subsonic speeds for significant portions of the journey. A subsequent service to Singapore faced an even shorter lifespan. By December 13, 1977, after only 3 flights, the route was halted due to environmental protests from the Malaysian government regarding sonic booms over the Straits of Malacca.
Ultimately, Concorde, though it made it into passenger service, it suffered the sonic boom problem that had dogged the early Boeing project. The Americans banned supersonic flight over the continental United States. Some people said that was in retaliation. Whether it was or wasn't is neither here nor there. It meant that Concorde could only fly supersonic over the Atlantic.
It couldn't meet any of the requirements that we couldn't meet, and it still can't, but there's so few of them that nobody cares. They don't meet the sonic boom, and they don't meet the takeoff noise, and I guess there are probably only half a dozen or so flying in each airline.
Concorde will never be profitable in the sense of making back the money that it cost to buy or to develop. As far as the airlines are concerned, well, Concorde makes money on an individual flight-by-flight basis because it can charge very high tickets to the kind of luxury passengers that are there.
The system exists now because it's unique and it's high cost and it's one of a kind, and if you want to make a splash, you go over on the Concorde. And okay, Betsy and I were on it. Well, we went over, took off from Washington about 4:30 we took off from Washington about 4:30 in the afternoon, and in a hotel room in London, 9 o'clock. It's great.
Yet one hidden chapter of the Boeing 2707 saga would eventually democratize global travel. On December 22, 1965, Boeing's William Allen and Pan Am's Juan Trippe signed a commitment for 25 units of a new transport concept. While the 2707 had been Boeing's primary focus, this new project was treated almost as a secondary concern. Boeing chose simplicity, scaling up the existing 707 architecture. They designated it the Model 747, though the world would come to know it as the Jumbo Jet.
The 747 is an amazing story. And it started back right after the Vietnam War, where the government said, We need to move a lot of material and a lot of people around the world in a hurry.
The 747 was actually developed in tandem with the Boeing supersonic project. And the aim was to put in the 747 what you couldn't get in the supersonic aircraft, which was freight. It was just meant to be a big cargo plane in the first place.
The Boeing company in 1965 decided to scale up the 707, I think as a freighter originally, but it was soon realized you could pack so many people into these aircraft and fly them at high subsonic speeds that it was very, very commercially viable, made great sense.
When the dream of supersonic commercial flight faltered, the 747 stepped in to fill the void. Entering service in 1970, it ignited a true revolution, making long-distance flight affordable for the average family. The era of mass aviation had arrived. Historically, over 1,500 of these queens of the skies were produced, dwarfing the mere 14 Concordes that ever reached commercial service.
I think the 747 will still be flying in 20 years. It's one of the major developments of this century in aerospace.
Curiously, there's one hangover from the old supersonic project that ended up in the 747, and that was seating arrangement. When they transformed the 747, the jumbo jet, into a passenger plane, because it was wide-bodied, they could put in a couple of rows, you'd get a lot more seats. And that was the original dream that the supersonic transport had been born with.
Boeing's fascination with high speed didn't vanish with the 2707. In a later collaborative effort, NASA utilized a retired Soviet SST, the Tupolev Tu-144, often called Concordsky, as a flying laboratory.
The Russian SST actually flew just a few months before Concorde. And when people saw it, they said, gosh, that looks like Concorde. And that's because, of course, the Russians had stolen, line for line, page for page, the plans of the Concorde and built it themselves.
The Tu-144 never succeeded internationally. It was difficult to operate and fundamentally compromised. Its final mission was to help modern engineers understand the environmental issues that had plagued the Tu-707. NASA and Boeing envisioned a successor capable of carrying 300 passengers at 2,400 kilometers per hour, crossing the Pacific in just 4.5 hours. Ironically, these were nearly the exact specifications of the Tu-707, cancelled decades prior.
The main thing that's happened is you've gone to high bypass ratio engines, and the engine cycles changed, and the noise problem isn't as bad as it used to be with a pure jet.
Years of research provided better insights into supersonic flight, but the fundamental barriers remained: high operational costs, noise, and emissions.
There is no technology anywhere that I'm aware of that says that you can bypass, overpass, whatever, the supersonic barrier. It's there. The boom just has to be there. There's so much energy involved when you go through that barrier.
The dream of supersonic transport was an engineer's dream. It was a politician's dream. It was Kennedy's dream. The passengers wanted something different. They wanted cheap tickets, they wanted reliable service, they wanted comfort, and that will always be the future of the airline business.
Now, as a matter of fact, if somebody were to ask me today, will there ever be a supersonic airplane in the U.S., built by the U.S., I would say first you got to define what you mean by supersonic. There may very well be a more advanced Mach 2 airplane, larger, more economical, and so forth than the Concorde. They may very well be, I don't know that. But we are still today not ready in materials to go to Mach 3. We just don't have the wherewithal to do it.
Yet the ambition persists. Even in the 2020s, aerospace companies are developing new boom reduction technologies to push the limits of speed. While the legendary SR-71 Blackbird once routinely cruised at Mach 3 using titanium, modern materials science continues to evolve. As we move through the 21st century, the goal remains to make the dream of routine supersonic travel a reality. This is the enduring legacy of the Boeing 2707, the most influential aircraft that never actually left the ground.
In 1966, the aviation community celebrated the remarkable contributions of British aviation pioneer Sir Frank Whittle to the industry. A quarter of a century earlier, this visionary aeronautical engineer had revolutionized air travel with his groundbreaking invention of the jet engine. On May 15, 1941, an experimental Gloster E-2839, powered by Whittle's W1 jet engine, soared into the skies above Cranwell, flying for 17 minutes and achieving a top speed of 545 kilometers an hour. By the war's end, the Gloster Meteor had shattered world speed records, reaching an astonishing 975.46 kilometers an hour. Sir Frank Whittle, alongside German inventor Hans von Herrhein, accelerated the evolution of jet aircraft, making them the preferred choice for long-range travel in just a few decades. While the 1930s epitomized luxury in air travel, the 1950s witnessed a surge in faster and more affordable flights, democratizing air travel for countless individuals. Whittle's groundbreaking achievements propelled British aerospace to the forefront of the aviation industry. American companies concentrated on piston engine airliners, leaving the field free for the British to race ahead with jet technology.
Once again, the eyes of the world turn to Britain as aircraft manufacturers stage the greatest flying show on Earth at Farnborough in Hampshire.
By 1952, Britain was experiencing a surge of national pride, fueled by its rapid advancements in jet technology. The pinnacle of these achievements was showcased at the prestigious Farnborough Air Show, featuring standout aircraft such as the Supermarine Swift, the Gloucester Javelin, and the Handley Page Victor, alongside tantalizing glimpses of future airliners.
The Bristol Britannia, a turbojet capable of carrying 104 passengers, will soon be in regular service. Now the Victor, Britain's crescent-wing bomber. Powered by 4 Sapphire jet engines, it's already in super priority production for the RAF. Few details have been released about the Victor, but there seems little doubt it's intended as Britain's #1 atom bomber. Huge delta-wing Avro Vulcan. Britain pioneered and perfected the delta-wing design. Now the Flying Darts, Avro 707s, the fighters from which the Vulcan was developed, form up in escort. Farnborough, our showplace of the air, proves once more that Britain is leading the world into this new jet age. As we looked at the latest aircraft that have swept Britain to the forefront of aviation.
However, the journey wasn't without its challenges for Britain's high-performance jets. During the air show, pilot John Derry was demonstrating the capabilities of the de Havilland 110 fighter. Just 4 years earlier, Derry had made history as the first British pilot to break the sound barrier in a British aircraft.
But those who watched during those 5 days could never know the feelings of the men whose job it was to take an aircraft through the sound barrier again and again. And perhaps as we thrilled to their daring, we almost forgot that on each and every flight, death flew with them. But those who were there on the 6th day will never forget. For it was on that day that a force developed in Derry's black aircraft, and he and his observer flew in another. The aircraft broke through the sound barrier and then flew low over the airfield. Now the split-second disaster in slow motion.
Tragically, as Derry initiated a climb, the wings of the aircraft failed, causing the engines to detach and plummet to the ground. While one engine landed without incident, the other crashed into a crowd of spectators, resulting in devastating consequences, killing 29 people and many more were injured. An investigation found that the de Havilland's D-nose leading edge arrangement was unsuited to the stresses of supersonic flight in such a heavy aircraft. The tragic incident prompted a widespread overhaul of safety regulations governing air shows.
the heavy death roll is mute testimony of the dreadful tragedy. Almost at once, Derry's friend Neville Duke flew a Hawker Hunter through the sound barrier again. Flying, like progress, must not stop. John Derry was an explorer in an unknown world, whose barriers can only be penetrated by such men as he. Their courage and skill have won us great victories in the skies, and they will go on.
In the years following World War II, Britain's aeronautical industry thrived. The Vickers VC-1 Viking exemplified a new era of passenger aircraft design. Derived from the Vickers Wellington bomber, this twin-piston engine short-range airliner served airlines worldwide for many years. Crucially, for jet propulsion development, a modified Viking equipped with Rolls-Royce Nene turbojets emerged as Britain's first pure jet transport aircraft in 1948. However, the initial British passenger jets introduced into service were powered by turboprop engines. With the Americans focused on piston engine airliners, the British enjoyed a wide open field for advancement with the release of the Vickers Viscount and the Bristol Britannia. Turboprop engines harness the high-temperature gas within a jet engine to propel the propellers, delivering superior power and speed compared to piston engines, along with enhanced fuel efficiency compared to turbojets. Advancements in technology elevated support roles to a more technical level.
For example, to keep each airliner in the air today, over 100 workers are needed on the ground. But the safety of operations also depends upon the proper maintenance of planes. For this reason, many skilled mechanics must be employed. Their work is highly specialized, and those who direct or supervise such work must hold a federal government certificate and ratings depending upon the type of work they do. For example, mechanics qualified to supervise work on general maintenance, including dismantling, welding, or fabricating, must hold what is called an A, or aircraft certificate. Others, who supervise and approve engine work only, are required by the Civil Aeronautics Authority to hold an E, or engine certificate. But no matter what their chosen field may be, regular apprenticeship courses or equivalent technical schooling is required.
BOAC, Britain's premier airline, leveraged turboprops throughout the 1950s, exploiting their increased power and range to pioneer non-stop global flights.
Emerging from the war with tremendous military air strength, but little civilian, our airlines have since then been striving to make up for lost time. Informed observers of the British aviation scene believe that the United Kingdom has two trump cards to play in her bid for leadership in the sky. The bold, far-sighted policy of executives like Whitney Straight, and her acknowledged genius in the design of new aircraft and engines. They point to Britain's intensive pioneering of gas turbines, prime movers which will outstrip by many hundreds of miles an hour the speeds accepted in present timetables.
Intense competition characterized the aviation market, with nations like France and India striving to offer the most luxurious travel experiences.
For you, the new pleasure of travel in the latest luxury airliners, twice as fast, with personnel whose courteous attention is world famous.
I think we ought to have the lettering much bigger. Air India, the route of the magic carpet.
A diplomat, a movie siren, a world-renowned musician is usually aboard, and maybe sitting beside you. And remember, breakfast in bed.
Britain, committed to leading the aviation industry, introduced the world's inaugural turboprop aircraft in 1948. The Vickers Viscount, a medium-range airliner manufactured at the Vickers factory in Weybridge, epitomised this innovation. Quieter and smoother than piston engine counterparts, the Viscount accommodated approximately 50 passengers and soared to become one of the most favoured airliners. A total of 445 Viscounts were manufactured and distributed to airlines worldwide. Powered by 4 Rolls-Royce Dart Mach 525 turboprop engines, the Viscount boasted an operational altitude of 25,000 feet. Later variants featured a new fuel system, a two-pilot cockpit, more powerful engines, and increased weight. In 1949, the Bristol Brabazon took to the skies, a 100-seater airliner developed for the transatlantic market. Unfortunately, despite its promising start, the airplane never entered mass production and the prototype was dismantled for scrap. The Bristol Type 175 Britannia turboprop, affectionately known as the Whispering Giant, earned its moniker for its serene and smooth flight experience. Although it made its maiden flight in 1952, setbacks, including the loss of two prototypes to icing issues, delayed its official launch until 1957. As a result, only 85 Britannias were manufactured. Yet the aircraft garnered widespread acclaim as one of the finest turboprop airliners ever engineered. BOAC procured 18 of these long-range airliners out of the 312 produced, pioneering non-stop transatlantic flights between London and New York in both directions. Additionally, the Royal Air Force operated several Bristol Britannias, utilising them until 1975, when they were retired from military service and sold to various African, Middle Eastern and European airlines, which operated them until the 1980s. Meanwhile, behind the Iron Curtain, the Soviet Union was making significant strides in jet airliner technology. The arrival of the Tupolev Tu-144 at the Paris Air Show in 1959 astounded Western observers with its imposing size and advanced features. The airplane features swept-back wings at 35 degrees. Its Kuznetsov NK-12 MV turboprops were the most powerful ever made, and its landing gear was exceptionally long because of the huge propellers.
The world's largest airliner with seats for up to 220 people, a range of 6,000 miles, so that it can fly easily from Moscow to New York non-stop. Well, the Russians have been photographing our planes in great detail while they've been here, so now no doubt they're going to allow us the privilege of taking a few pictures of theirs.
The Tu-114 served on international routes until it was surpassed by the Ilyushin IL-62 and reassigned to domestic flights. Later, it was repurposed for military use, operating in the Soviet Army and Air Force until 1991. Despite the efficiency of turboprops in passenger aviation, Britain remained eager to incorporate turbojets into its commercial fleet. In 1952, BOAC introduced the de Havilland Comet, the world's inaugural jetliner and a symbol of British aviation prowess. The American business magazine Fortune hailed 1953 as the year of the coronation and the Comet. Distinct from the clamour of piston engines, the Comet emitted a distinctive high-pitched whine during approach. Cruising at altitudes of up to 40,000 feet, passengers enjoyed pressurized comfort.
Early in the year, a brilliant new all-British achievement made headline news throughout the world. The Comet made its debut on a journey from London Airport to Johannesburg. 4 de Havilland Ghost jet engines power this mighty passenger-carrying craft that the British Overseas Airways Corporation have adopted for their major air services. The Comet was soon airborne for its first historic flight, London to Johannesburg, a journey of more than 6,000 miles. Quickly and smoothly, the Comet climbed to 40,000 feet. At some 500 miles an hour, the Comet flashed over Europe. Always a new land, a new country to be seen, no time to be bored with the journey. Soon the Alps were below. Speed, reliability and comfort, these are among the Comet's greatest assets, backed by BOAC service second to none. Stewardess Audrey Cartmel looked after the passengers. High over Africa it flew, then below, white patches showing where gold had been wrested from the earth told the passengers that they'd reached their destination. This was Johannesburg. The Comet had made the 6,000-mile journey in 23 hours and 40 minutes, less than a day from London. The Comet's achievement thrilled the world and set higher than ever before the prestige of British aircraft and airways in this jet age.
Unfortunately, Britain's aviation future faced unforeseen challenges. In its debut year, one Comet suffered damage and another failed to become airborne due to an issue with the leading edge of its wings. Tragically, worse incidents were to follow. In May 1953, a Comet crashed during a tropical storm just 6 minutes after departing Calcutta Airport in India. Initially attributed to adverse weather, the crash raised concerns. Then, in January 1954, another Comet exploded at 30,000 feet en route from Rome to London, marking a devastating turn of events. There was no obvious explanation for the crash, which killed 35 people. Investigators ordered some modifications before allowing the airplane back into service, but they had no real idea what caused the accident. 3 months later, another tragic incident unfolded as yet another Comet disintegrated over the Mediterranean. The entire fleet faced an immediate and indefinite grounding, while experts delved into the root cause of these calamities. Leading the investigation was Sir Arnold Hall, a distinguished aeronautical engineer renowned for his contributions, including designing the compressor for Frank Whittle's pioneering jet engine. The Ministry of Civil Aviation constructed a massive tank, spacious enough to accommodate a Comet, and filled it with water to replicate the atmospheric pressure experienced at 35,000 feet. Through exhaustive testing, Hall determined that metal fatigue lay at the heart of the Comet disasters, stemming from the recurrent pressurization and depressurization of the aircraft cabin. Further analysis revealed that the window supports were punch-riveted rather than bonded, exacerbating the structural vulnerabilities. Consequently, the Comet underwent significant redesign, with the insights gained informing safety improvements across the aviation industry. In a curious aside to the investigation, novelist and aeronautical engineer Neville Shute briefly served at the de Havilland Aircraft Company in the early 1920s, adding an unexpected dimension to the narrative. In 1948, he published No Highway, a best-selling thriller about an aircraft engineer who becomes convinced that a new airliner type is fatally flawed due to metal fatigue. Neville Shute christened his fictional airliner The Reindeer, sparking speculation that the novelist was subtly expressing concerns about the Comet's design in a veiled manner, given the association of Comet with one of Father Christmas's reindeer. In 1951, Shute's book was adapted into the widely acclaimed film No Highway in the Sky, featuring James Stewart and Marlene Dietrich. With the Comet sidelined, the Soviet Tupolev Tu-144 stood as the sole civilian turbojet operating passenger routes. Derived from the Tu-16 Badger strategic bomber, the Tu-104 underwent rigorous pressure testing in a water tank before entering service with the Soviet national airline Aeroflot in 1956. Meanwhile, British firm Avro set its sights on transatlantic markets. On September 1, 1950, Avro unveiled the Avro Ashton, an experimental jet airliner propelled by 4 Rolls-Royce Nene 6 turbojets. Insights gleaned from the Ashton project were integrated into the development of the Avro C-102, manufactured in Canada and marking the first civilian jet aircraft to land in the United States.
In Toronto's Malton Airport, a Canadian Avro jetliner, a 4-jet 60-passenger transport, takes off with a cargo of mail, climbs quickly to 20,000 feet, and heads for New York. "59 minutes later, she zooms over Idlewild Airport, cutting in half previous airline records for the 370-mile trip. The plane, called Canada's idea of a better mousetrap in the aviation field, is the first jetliner to carry international airmail in this hemisphere. On Rome's Ciampino Airfield...
Nevertheless, Britain remained resolute in reclaiming its dominance with a revamped Comet. The government extolled the virtues of the new airliner, investing considerable effort in linking the successes of previous aircraft to the anticipated triumph of the Comet. Mindful of the public confidence shattered by the early Comet tragedies, de Havilland dedicated several years to meticulously refining the new design. Despite pressure to change the name and create distance from the earlier model, de Havilland stood by the brand and by 1957 had produced the Comet Mach 4. The new Comet model underwent a meticulous inspection process, including rigorous pressure testing in a water tank, supplemented by hydraulic rams exerting additional stress on the wings. The setback experienced by the Comet proved to be a fortunate turn for the American aviation industry, which seized the opportunity to bridge the gap with its groundbreaking Boeing 707 jetliner. Derived from the military KC-135 Stratotanker, the 707 boasted 70% more power than the Comet, accommodating 179 passengers and double the fuel capacity. Eager to secure a foothold in the lucrative transatlantic market, the Boeing 707 arrived in the United Kingdom for testing in preparation for launching flights between Britain and the United States.
The biggest, the heaviest and the fastest airliner flies into London Airport. It's the Boeing 707, America's rival to the Comet 4 in the race to provide the first jet airline service over the Atlantic. The Boeing, its 4 jet engines screened by huge silencers, is here to pass noise tests before it can use the airport. The massive interior will carry 165 economy-class passengers, flying at heights that make individual oxygen supplies necessary for emergency use.
Galvanized by the American competition, de Havilland pressed forward with the Comet. Despite its shorter range compared to the 707, BOAC committed to purchasing 20 aircraft, recognizing that the Comet's ability to operate from existing runways and reach numerous smaller airports along BOAC's routes was advantageous. This marked the beginning of the end for BOAC's piston engine fleet. According to pilot John Cunningham, despite its advanced technology, the new aircraft proved to be more user-friendly than its predecessors.
How does she compare with the earlier Comets?
Well, it's very much more lively, having more than twice the power of the earlier Comets. Its flying qualities are much improved over the earlier Comets, partly as a result of the last 8 years' flying experience on Comets. And generally, I think it's an easier aeroplane to fly than the earlier Comets.
Are you absolutely confident that you straighten out the problems that caused the early Comet disaster?
Yes, absolutely. We've learned an enormous amount, of course, in the last 8 years, and particularly in the last 4 years, as a result of the Comet inquiries. A lot of research and development work has been made on structures, and we have today in the Mach 4 an aeroplane that embodies really all the best experience any manufacturer has had.
The Comet features simplified controls to aid flight crews in managing the increased takeoff and landing speeds. Its inaugural challenge came in the form of the race to conquer the Atlantic. Pan Am was confident its 707 would be the first, but BOAC had a surprise in store.
It was a great race and Britain won it. Comet 4 Delta Charlie flies into New York, the first jet to carry fare-paying passengers across the Atlantic. And Comet 4 Delta Bravo clinched the victory with a record non-stop west-east flight in 6 hours, 7 minutes on the same day. The first commercial jet service across the Atlantic is established, and BOAC are flying it. For the 28 passengers, it was a great occasion. But for the team who flew her and the men who built her, Delta Bravo's capture of the blue ribbon of the Atlantic Airways was final triumph. Such men as her captain, Tom Story, and the man whose genius created her, designer Tim Wilkins. Mr. Wilkins, you've designed a wonderful aeroplane. Have you had much in the way of trouble on the way?
Well, we had, of course, our full measure of troubles, the Comet 1, which was designed some time ago, and was, of course, a very big step forward in the aviation airline business. Anyway, after the troubles, we did decide to carry on with the Comet and retain the name and bring it back.
Comet's story stretches back into the war, when Britain's all-out effort to produce fighting aircraft gave her no chance to develop civil types. But Sir Frank Whittle's first jet engine gave the opportunity to forge ahead again. For 13 years, development of the Comet went ahead at de Havilland's. First, Comet 1 and failure. Then, the bigger, faster, safer and better Comet 4. But America's research was bounding forward, and after the setback to Comet 1, it looked as though the Boeing 707 would be first across the Atlantic. Everyone believed the race had gone to the United States, and Pan American spent an estimated £500,000 advertising the first transatlantic jet service. Everyone believed it except de Havillands and BOAC, and they'd a surprise up their sleeves. Early delivery of not one, but 3 Comets. And that did it. More than a month ahead of their own schedule, and 3 weeks in front of the Boeing's expected entry into service, BOAC sent off the first regular jet service across the Atlantic. Yes, Comet 4's in business. Britain's aircraft industry can chalk up its greatest post-war triumph.
As well as the Comet 4, Britain was counting on another jetliner to keep it in the forefront of the jet race.
So George, what can the VC10 do?
Well, the passenger accommodation varies between 108 and 150 people according to the class layout. Cruising speeds in the 600 mile an hour class. Cruising height between 40 and 50,000 feet according to the length of the trip. The range, London, New York, non-stop.
Why are the engines on the fuselage and not on the wing?
Because the aeroplane has to be better than the American jet, which will be in service some years before it. And the biggest problem in these big jets is aerodrome performance. If you keep the engines away from the wing, so that you've got them pulled back with a clean wing, you can develop a takeoff performance of the aeroplane much superior to the one which you have with the engines on the wing. You have a completely clean, unbroken leading and trailing edge flat, and you get out of difficult aerodromes at greater weights.
What about for the passengers? Is there any improvement for them?
Yes, so there's going to be a big advantage in passenger comfort because the noise and vibration, whatever there is behind them, and forward of that line, say, the interior is going to be pretty quiet.
The VC10 and the imposing Vickers Vanguard turboprop emerged as heralds of the aviation future.
Mock-up of the Vickers Armstrong VC10 indicates the shape of things to come in British airliners. The cost of the mock-up is £500,000, showing that building large airliners is a big money business. The VC10 will carry a maximum of 150 passengers at about 600 miles an hour, the power being provided by 4 Rolls-Royce Conway engines. It will be in the air by 1961. The engineers concerned believe that engines mounted in the rear are best. But the VC10 isn't the only aircraft built at Weybridge. There's the Vanguard too. Turboprop, twice as big as the famous Viscount, it will fly on BEA routes next summer. The VC10 could reduce tourist fares by 50%. Roll on the day when it's in the air.
The Vickers VC10 was slated to revolutionise air travel as the premier large jet airliner equipped with 4 rear-mounted engines. Produced at the British Aircraft Corporation's Weybridge facility, this 150-passenger aircraft aimed to claim the title of the world's most potent airliner. Positioning its 4 Rolls-Royce Conway 301 turbofan engines at the rear substantially mitigated cabin noise. Additionally, the aircraft boasted a reinforced frame with over half composed of solid steel and alloys, along with fully redundant systems to bolster safety and reliability. Despite fervent marketing efforts to showcase the VC-10's prowess, especially amid increasing American competition, Vickers faced precarious financial circumstances due to tepid demand for the jetliner. The British government intervened, pressuring BOAC to expand its orders to enable Vickers to break even, if not turn a profit. BOAC harboured reservations regarding the VC-10's fuel efficiency, especially upon discovering that the Boeing 707 boasted a lower cost of £4.10 per passenger mile compared to the VC-10's £4.24. This revelation, which found its way into the media, eroded customer confidence in Vickers. Ultimately, BOAC placed orders for 12 standard VC-10s and 35 Super VC-10s, although it scaled back its standard order to 7 by 1964 as airline expansion stagnated. The British government bought the excess VC-10s and used them as military transports for many years. The Super VC-10 introduced enhancements such as an additional fuel tank in the fuselage and adjustments to engine positioning, effectively addressing issues with tailplane buffeting and fatigue related to thrust reverser operation. Despite the political complexities surrounding its development, the VC-10 swiftly garnered popularity within BOAC's fleet, acclaimed by both passengers and crew for its reduced noise levels and heightened interior comfort. Derived from the Vickers Viscount, the Vickers Vanguard represented a significant evolution. Its redesigned fuselage boasted a double bubble cross-section, maximising internal space and augmenting cargo capacity. Powered by new Rolls-Royce Tyne engines, the Vanguard attained cruising altitudes of 30,000 feet, establishing itself as one of the swiftest turboprops ever constructed. Notably, the 4 engines demonstrated exceptional reliability and efficiency, facilitating a range of nearly 3,000 kilometres. Unlike earlier aircraft, the Vanguard's wings contained integrally machined skins of light alloy to provide span-wise stiffening at low cost, and 3 shear webs rather than the single spar in the Viscount wing. Operating the airplane demanded considerable physical strength, as all flight controls were manually operated without power assistance. Additionally, adjusting thrust resulted in significant yaw, given that all 4 sizable propellers rotated in unison. Regrettably, by the time Vanguards entered the market, turbojets had surged in popularity, leading to limited demand for the colossal turboprop. Trans-Canada Airlines and DEA stood as the sole customers, with only 43 Vanguards ever manufactured. Nevertheless, BEA Vanguards proved invaluable on bustling European and UK trunk routes, boasting 139 passenger seats. Despite initial challenges, the Vanguard proved to be remarkably profitable. On shorter distances, it even matched the travel times of jets servicing the same routes. With increased passenger capacity, ticket prices plummeted, prompting a shift in travel habits as people began considering medium to long-distance flights over driving. Airline travel started to become accepted as a fact of everyday life. Despite the challenges faced by the British aviation industry, the government seized the opportunity to host the King of Nepal on a highly publicised tour of the Vickers Armstrong factory during his visit to England in 1960. Welcomed by Brigadier Generals Charles Dunphy and Sir George Edwards, the King was escorted to the Vanguard assembly area and presented with completed aircraft on the tarmac. While media attention primarily focused on the civilian airliners, the primary objective of the visit was to showcase Vickers Armstrong's array of military hardware, a cornerstone of Britain's vital export industry. The British Aircraft Corporation 111 emerged as the second short-haul jetliner to enter service, undergoing testing in the early 1960s. Tragically, the prototype met with disaster on October 22, 1963, resulting in the loss of all lives on board. Subsequent investigation revealed the occurrence of a deep stall attributed to diminished airflow to the tailplane due to the obstructive effect of the aft-mounted engine nacelles at high angles of attack, impeding the aircraft's ability to recover normal flight. Stick shakers and stick pushers were added to the control system, and the wing's leading edge was redesigned to smooth airflow into the engines and over the tailplane. Another test variant experienced a rough landing at the Wesley Test Centre, resulting in severe damage to its landing gear and undercarriage. Despite this setback, the airliner proceeded into production and enjoyed a successful career as a commercial transport for many years. The pioneering jet airliner to enter production in continental Europe was the Sud Aviation Caravelle from France. This graceful twin-engine turbojet made its maiden flight in 1955 and commenced service 4 years later on the Paris-Rome-Istanbul route. With a seating capacity of up to 128 passengers in a single-class configuration and manned by a flight crew consisting of 2 pilots and 1 engineer, the Caravelle epitomised efficiency and elegance in air travel. Although initially trailing in jet airliner development, Lockheed's propeller-driven airliner, the Constellation, emerged as one of the most beloved post-war passenger aircraft.
Now watch this. Feather 1. Feather 1.
Feather 2.
Feather 2.
Look at that, on 2 engines. Purring along just like a kitten. You haven't seen anything yet. Feather 3.
Feather 3.
Boy, oh boy, look at that. On 1 engine. Going along just as steady as you like. Only a Constellation could do this. Why do we have all that tremendous reserve of power? 'Cause, my friends, power means safety. That's why this Super Constellation is the most dependable airliner in the world today. Okay, Hugh, bring in 1.
Unfeathering 1.
As the first widely used pressurized airliner, the Connie graced the fleets of airlines worldwide.
Gear down.
Gears coming down.
Eastern 601 cleared to land. The captain will reverse the pitch of the propellers and push the air forward and just stop the plane. There. You see, that acts as a powerful brake. So next time when you're riding in an airliner and you hear the engines roar soon after you're on the ground, remember that's what he's doing, reversing the props to stop the airplane.
Maintaining its relevance throughout the 1940s and 1950s, until the emergence of jet transport ultimately led to its retirement. Jets revolutionized mass transportation, ushering in a new era of air travel accessibility and efficiency. America envisaged a golden future for its new Boeing 707 airliner.
1000's destination, London. Luggage was prepared for loading, and all other routine pre-flight activities were taking place. 1000 seemed to be just another flight to London, in all respects except that its passenger list was twice as large as on ordinary trips. Flight 1000 was airborne, but no plane was used. This was the first of so-called airline paper flights, a complete simulation of an actual flight that's been repeated more than 2,000 times since. The reason? To prepare for the revolution in transportation that is now here, the advent of commercial flying by jet clipper. In those early days, weather information for Flight 1000 and all the other paper jet flights was gathered as carefully as if real jets were to cross the Atlantic, gaining invaluable advance information about jet travel. For example, it is now known that at the altitudes at which jets cruise, generally 30 to 40,000 feet, flying will be above the weather. After years of paper flights like number 1000 and many hundreds of real flights with prototypes, the jet age is now here. The jet age begins before takeoff, at the airline's new terminal, now under construction at Idlewild Airport, New York. Jets are parked around it, as in this model. Passengers will board by walking along a covered ramp directly to the cabin level. Ground transportation delivers travelers directly to check-in counters. The circular design of the terminal, along with its unique cantilever roof, will assure speed of service and convenience for passengers. This is it. The first American commercial jet capable of economical transatlantic service. The Boeing 707 Jet Clipper. First to go aboard cargo and mail. Cargo shipments will be able to reach Europe in just 6.5 hours. A letter posted in London or Paris after the close of business may arrive in New York the same night and be waiting for the addressee at his breakfast table or office the next morning. Speed is a byword for every part of jet operations, since with some arrangements of seats, more than 150 passengers can be accommodated. There's an entrance at the back and the front, while plane servicing facilities are on the far side. One indication of the staggering impact of jet travel, every one of the airline's dozens of jet planes can carry as many people in a year's time as the biggest ocean liner.
The Boeing 707 boasted 35-degree swept-back wings and was powered by 4 Pratt & Whitney JT3C turbojets, representing the pinnacle of aviation technology. However, before the 707 could enter into service, there were still challenges to overcome.
More jet news from Seattle, USA, where the new Boeing jet airliner, America's challenge to the Comet, is all set for her first taxiing tests. All seems well with the 95-ton giant, then a sudden collapse as the port landing gear buckles. Fire trucks race to the scene as the pilot and crew scramble out of the damaged aircraft. The jetliner cost nearly £6 million to build. Experts fear that its first test flight will be delayed many weeks.
As the design underwent refinement, excitement and anticipation mounted.
Takeoff, without any need for engine warm-up. With outside noise now reduced to no more than that of propeller-driven planes. Capable of traveling at 575 miles per hour or more. Much higher and faster than you've ever flown before. The first passenger jet clipper to fly the Atlantic. Because of its greater size and speed, it will do the job of several of the biggest propeller-driven planes. Welcome aboard. Welcome aboard the spacious cabin, attractively decorated, air-conditioned but draft-free. Newly designed individual overhead light units are an innovation. Roominess extends even to the powder rooms, which look like those in a private home. And a new sensation, complete absence of vibration. Near sonic speed, but inside one of the most stunning discoveries. There is no feeling of movement at all, no vibration, hardly any sound. A new concept in air transportation. The travail has been taken out of travel.
Ladies and gentlemen, this is your captain speaking. We're now at cruising altitude, 35,000 feet. Our flying speed is 575 miles per hour. In addition, we're benefiting from a substantial tailwind by courtesy of the jet stream. Hence, our ground speed is now approximately 658 miles per hour. Indications are that our arrival at London Airport may be ahead of schedule. I'll be speaking with you again from time to time. Thank you.
Despite being edged out by the unexpected transatlantic crossing of the Comet 4, the Boeing 707-120 made its debut on October 26, 1958, just 22 days later, with an impressive flight from New York to Paris, including a fuel stop in Newfoundland. The 707 quickly overshadowed British jetliners in popularity, but a series of unfortunate incidents less than a year later shook public confidence in the airliner. The jet encountered a string of mishaps, including emergency landings prompted by failures in the hydraulic system. One crippled aircraft was captured on film landing at Idlewild Airport, trailing a dramatic plume of flames as it came to a stop. Despite the precautionary deployment of emergency slides, most passengers disembarked via the stairs. The day before, a Qantas 707 had suffered an engine failure 150 miles out to sea. Fortunately, the aircraft with 82 people on board was able to make it safely to land on the other 3 engines. The first major accident involving the Boeing 707 occurred on August 17, 1959, when a test flight ended tragically with a crash shortly after takeoff on Long Island, New York, claiming the lives of all 5 crew members. Rescue teams worked diligently to salvage as much wreckage as possible to aid in the investigation, which was spearheaded by the US Civil Aeronautics Board. Investigators determined that the pilots were conducting simulations of engine failure on 2 engines on one side when the accident occurred. In response to the findings, the Federal Aviation Authority implemented a new regulation stipulating that exercises involving 2 engine failures could not be conducted below 5,000 feet. Amid concerns that the flagship airliner might suffer a fate similar to the ill-fated Comet, some policymakers advocated for grounding the 707. However, Boeing staunchly defended its jetliner.
Saturday's Long Island crash, when the crew of 5 were killed, followed more than a dozen incidents ranging from minor electrical faults to landing gear trouble and wheels dropping off. These facts were put by our reporter Douglas Brown to a Boeing airplane company executive, Mr. Bromwich.
Well, it is true that we've had a certain number of difficulties with the 707, but these troubles have not fallen into any pattern. That is, there haven't been any consistent troubles with the 707. We have had some hydraulic system troubles, but as far as the major incidents are concerned, they've all been a little bit different one from the other. So we can't say that we have a family of troubles here that we can really work on.
Awful lot of them, though, hasn't there?
Well, I suppose so, but every airplane that's introduced into service has difficulties at first. We probably have had a little bit more publicity than the other people have had because, after all, it's a new device, and people are interested in what happens to transportation devices. Witness the headlines that occurred when the Queen Mary ran into, or was it a freighter ran into the Queen Mary?
Influential people in the United States themselves have called for the aircraft to be grounded.
Well, of course, we had a member of the House of Representatives call for it to be grounded, but there are 486 members of the House of Representatives, and I'm sure that out of these 486 people, you could find at least one who likes to get his name in the paper.
Is there anything in the criticism that the 707s should have been tested more on the ground before they were allowed into the air?
Well, from the Boeing airplane point of view, I don't know what we could have done. We've spent an awful lot of money on the airplane. We've actually started designing the airplane in 1952 and first flew the airplane in 1954. We have spent a great deal of money on it, and as we look back on the thing, I don't know that anybody in the company could say that there are things that we shouldn't have done in the way of testing.
Despite the setbacks, Boeing maintained a dominant position in the aviation industry. However, Douglas Aircraft was swiftly gaining ground with its own 4-engine jetliner, the DC-8. With Boeing beginning deliveries to Pan American Airways in October 1958, Douglas accelerated its testing schedule, sending 10 aircraft for certification by the Federal Aviation Administration by August 1959. A number of remedial works were carried out, including replacing air brakes with engine thrust reversers and adding leading-edge slots to improve low-speed lift. In September 1959, the first DC-8 entered into commercial service with Delta Airlines and United. 2 years later, a DC-8 achieved the milestone of becoming the first civilian jet to achieve supersonic flight. Although the Boeing 707 was often considered the superior aircraft, the DC-8 demonstrated remarkable staying power. By 2002, of the 1,032 707s manufactured for non-military use, only 80 remained in active service. In contrast, of the 556 DC-8s produced, approximately 200 were still in commercial operation, with some serving as cargo planes. Nevertheless, the era of jet aviation was undeniably dominated by Boeing. Throughout the 1960s, the aerospace giant solidified its hold on the American market and expanded its influence globally.
After 84 minutes, the first flight ends, and congratulations go to the pilot for blazing a new trail in the sky.
The Lockheed Constellation, affectionately known by many as the Connie. One of the most elegant and aesthetically pleasing aircraft to ever take flight. But being a thing of beauty was not its only grace. Lockheed took a giant technological leap to give birth to the Constellation. It was a leap so far ahead as to give Connie a lease on life, extending long after many of her prop-powered rivals rusted into obsolescence in the era of the turbojet. Her perfection of form and function can be traced to the dawn of commercial aviation. She was the end product of years of battles between the airlines for dominance of the skies. This struggle for economic survival would see the airlines and airliner evolve into their ultimate modern forms and unite the globe through air travel. In the late 20s, the fledgling American airline industry was still using aircraft like this Ford trimotor with its fixed landing gear. Technically primitive aircraft, by today's standards, and capable of short hops between cities only. Intercontinental airlines still relied on railways to ferry passengers for part of their trips. In this early age of aviation, the rules governing airlines and safety were still being written, sometimes lagging behind quickly evolving aerospace technology. Although not as dangerous as a ride with a daredevil barnstormer, a commercial flight could still be a risky proposition. A fatal crash in 1931 opened the world's eyes to the perils of flight.
That year, TWA Flight 599 came down in the Kansas prairie, killing famous football personality Knute Rockne and 7 others.
Rockne was a passenger on another type of trimotor, the Fokker F7. Unlike the all-metal Ford trimotor, it had wooden wing components, and moisture may have weakened the glue holding them together, causing them to fail during flight. Rockne was beloved by the American public, and the Rockne crash, as it became known, led to major changes in commercial aviation standards. Some improvement in speed, safety, and comfort were seen early in 1933, when the Curtiss Company launched the Condor airliner. Though it was a biplane and had a traditional frame and fabric construction, it had a tubular metal wing spar. The Rockne crash caused wooden aircraft to become the pariah of the airlines. As commercial flights became longer, passenger comfort became a greater priority. The Condor was the first aircraft to offer sleeping berths for overnight flights. Like today's airliners, it also had its own galley, providing fresh hot food and beverages for its passengers. Only about 40 Condors left the production line, and it did advance the passenger airliner, but an innovative new aircraft from Boeing would set the next benchmark for civil aviation. Boeing's Model 247 was breathtaking in comparison to anything else available, and all the airlines wanted it. It was faster than the fastest American fighter of the day, and it could beat the Condor across the USA by 8 hours. It was also a safer, more comfortable plane for its 10 passengers. It was all metal in construction and could fly on a single engine if one should fail. As well, the cabin was soundproofed and air-conditioned. The 247 was a solid design that could have dominated, but corporate greed got in the way. Boeing sold 60 of its aircraft to its affiliate airline, Boeing Air Transport, part of UATC, the predecessor to United Airlines. TWA and others were clamoring to get their own 247s, but their orders were to be postponed until the entire United order was fulfilled. Locked out, TWA and other airlines turned to aircraft manufacturers Douglas and Lockheed to build their new fleets. From Lockheed, the company that would one day create the Constellation, came the Model 10 Electra. Like the 247, it could initially carry 10 passengers, was of all-metal construction, and had twin engines. By this time, single-engine aircraft had been banned for all passenger and night flights. Kelly Johnson, then a student assistant at the University of Michigan, did much of the wind tunnel work on the Electra. He was a champion of the Electra's twin tails, which would later become a hallmark of Lockheed aircraft. Johnson would become a leading light at Lockheed and contribute to the Constellation's design. The Electra was a decent alternative to the 247, but Douglas had an aircraft in the works that would eclipse both of them and come to dominate civil air travel. TWA had turned to Douglas when their 247 orders had been rejected. The airline was looking for a new trimotor, but Douglas answered with a groundbreaking line of aircraft. The DCs, short for Douglas Commercials. These twin-engine, all-metal aircraft had the range and seating capacity to knock all competitors out of the sky. From the prototype DC-1 to the DC-2 to the DC-3, seating went up from 12 to 14 to 21. In terms of performance, the DC-3 could fly eastward across the USA in 15 hours, with just 3 refueling stops. Hundreds of DC-3s were constructed, compared to just 75 Boeing 247s. With so many of their planes in the air, Douglas had a major role in popularizing air travel. But for all the improvements that had taken place, aircraft manufacturers still had a long way to go in terms of performance and comfort achieved by a pressurized aircraft like the Constellation. Pressurizing an airliner would allow passengers and pilots to fly comfortably at higher altitudes and in the jet stream, cutting flight time and fuel costs. But it wasn't until 1937 that the first U.S. experiments got underway. It was in that year that the U.S. Army commissioned Lockheed to modify a standard Model 10 Electra with a new pressurized fuselage. The XC-35 was a watershed in aircraft design. It was an experimental aircraft constructed to prove that it was feasible to fly above the storms. Windows were smaller than found on the Electra for fears of a blowout. All these modifications allowed the XC-35 to fly at 30,000 feet and take advantage of the jet stream. The age of pressurized aircraft had arrived. With this new technology in hand, airlines were looking ahead to a time when they could offer non-stop, coast-to-coast flights and intercontinental flights, carrying enough passengers to make such trips economically feasible. To do so, they would need an all-metal, 4-engine plane, large enough to carry 40-plus passengers over a distance of 2,000 miles. In 1935, before the first DC-3 had risen into the air, United Airlines had expressed serious interest in an aircraft with these specifications and went to Douglas for help. 5 other airlines joined United's venture, including TWA, each contributing $100,000 apiece to the project. It was a small amount of money compared to the millions their investment might return. Douglas answered their challenging specifications with the DC-4E. It was a 4-engine aircraft that could carry 42 passengers, twice as many as the DC-3, a distance of over 2,000 miles. Like the later Constellation, it had a tricycle landing gear and a triple tail. It also had air conditioning, power-boosted controls, and production versions were to be pressurized. Such an aircraft could change the landscape of civil aviation, but as development costs increased, Pan Am and TWA lost interest. The prototype DC-4E did fly in June of 1938, and testing was successful, but it was too expensive, and performance was below expectations. The project was cancelled. In the end, the prototype was sold to Japanese Imperial Airways, who secretly reverse-engineered the aircraft to create the Nakajima G5N bomber. Japan wasn't the only nation gearing up for war. In the late 1930s, with communism and fascism at odds with each other and global tensions rising, war was a possibility, and aircraft manufacturers were preparing for the battles ahead while still keeping an eye on the civil market. Boeing attempted to re-engineer their B-17 bomber to create a new airliner, the 307. Boeing fused B-17 wings, undercarriage, and tail section onto a new, wider pressurized cabin to create the 307. It could fly its passengers in comfort high above any bad weather. However, because of its B-17 heritage, the 307 still had to utilize a tailwheel, making for less safe takeoffs and landings than an aircraft with tricycle landing gear like the DC-4E. Altogether, only 10 307s were sold. At this time, Lockheed was in development of their own four-engine passenger plane, the Model 044 Excalibur, which at first glance appeared to be a larger version of the Model 10 Electra. Howard Hughes would call for radical changes to this design that would reshape the Electra into the ultimate prop airliner. When Hughes gained control of TWA in 1939, he wanted an airliner which incorporated all the latest technology available. But no such aircraft were in the air. On top of his technical requirements, he was looking for great style and extra performance. Funding from the lucrative Hughes Tool Company was the only way Howard Hughes could pay for such an ambitious project. With cash in hand, there was little doubt that he would get his way. The final rendition of Lockheed's super airliner model was so different from the 044 Excalibur first proposed that it was also given a new name, the L049 Constellation. The plans for this streamlined, elegant aircraft fit Hughes's bill for style and performance. Lockheed designers, including Kelly Johnson, borrowed elements from other aircraft to create the Constellation. It was pressurized like the XC-35 and able to fly its crew and passengers at a ceiling of 24,000 feet. As well, its wings were adapted from those of Lockheed's P-38 Lightning, and its triple tail and tricycle landing gear were reminiscent of those of the Douglas DC-4E. Even with such a stellar design in the works, the more primitive Excalibur was not cancelled. It has been suggested that the more modest Excalibur concept had actually been kept in development to distract interest away from the greatly advanced Constellation. This was part of a ploy to keep TWA's monopoly of the Connie. Since Boeing had executed a similar maneuver to keep their 247 out of TWA's hands, there is little doubt that Howard Hughes was capable of such tactics. Just as the contracts were signed and planning for the Constellation prototype got underway, the world braced itself for war. Hap Arnold, head of the Army Air Force, voiced serious concerns over the rise of Nazi Germany. He stressed the need for a backup for the already planned B-29, a long-range bomber capable of striking the U.S.'s foes wherever they might be. Lockheed was now obliged to develop a bomber version of the Constellation, the XB-30, to play understudy to the B-29. The plan for the Connie's conversion was simple and lauded by the Air Force. Graft a Constellation's wings and tail section onto a new fuselage, housing bombs rather than passengers. In the end, however, there was no need for a backup bomber. Boeing delivered the B-29 Superfortress, and the XB-30 was cancelled. The end of the XB-30 was not the end of the Constellation's military career. In December 1941, when the war came to America, the military took control of the entire L049 project. The Constellation became the C-69, a high-speed transport aircraft for troop movement. In January of 1943, 4 years after Hughes proposed its groundbreaking design, the C-69 finally took to the skies. It was still several months before all engine problems were sorted out, and the aircraft was handed over to the Army Air Force. The second C-69 had a much more glamorous debut. Though it was still a military machine, it was allowed to be presented in striking TWA livery. Even more surprising was that Howard Hughes was allowed to pilot it trans-America on a record-breaking flight, a record at the time equal to any belonging to a modern fighter. A great deal of successful publicity was gained for all concerned, and the Connie was certainly winning hearts, but not that many orders. In fact, the total number of wartime deliveries was just 22. The Army was in desperate need of transport aircraft. They just weren't buying them from Lockheed. After the failure of the too advanced Douglas DC-4E, Douglas went straight back to the drawing board and produced a far less ambitious aircraft, originally known as the DC-4, with no E. It was quickly militarized into the C-54 Skymaster. C-54s had no pressurized cabin, and although they did incorporate a tricycle landing gear like the earlier DC-4E, overall they had a much simpler layout. This made for quicker production, easier service, and greater reliability, exactly what America needed in a wartime situation. With all of these advantages, the C-54s drained away the Constellation's military orders. Between 1942 and into the early post-war years, over 1,200 C-54s and DC-4s were produced. But the aviation marketplace was quickly changing. As World War II ended, aircraft manufacturers had to reverse course and focus their energies on the civilian market. A number of Skymasters found their way into post-war civil use, with some being retrofitted with pressurized cabins. It was in this early post-war period that the Constellation sales took off. Her extra size, more powerful engines, and pressurized cabin all became prerequisite features for a new generation of airliners. Luxury and comfort were now being offered, and the public was willing to pay for Constellation quality. However, Lockheed's competitors weren't ready to concede defeat. Boeing was looking to capitalize on the success and technology of the B-29. They started by creating a new tanker, the C-97. Like the proposed Lockheed XB-30, they took the wings and tail section of an existing aircraft, the B-29, and grafted them onto a new, larger double-decker fuselage. The C-97s were originally built in large numbers, as Air Force tankers and freighters. However, it didn't take Boeing too long to see the lucrative potential of the airliner market. The Boeing Model 377, or Stratocruiser, was an airliner version of the C-97. With its second deck providing much greater seating capacity and its extra range, the 377 looked like it would give the early Constellations some serious competition in the luxury airliner market. However, only 56 aircraft were produced. They certainly delivered all that was promised in the luxury department, but they proved uneconomical to run. Also, 2 serious accidents resulting from their complicated engine and propeller arrangement became a source of serious concern. Although the Stratocruiser had only a limited impact on the civilian airliner market, Lockheed and the Connie still had one more player to contend with. When the war was still raging, the Army had contracted with Douglas to make an advanced Skymaster prototype, longer and with more powerful engines, and at last with a pressurized fuselage. At war's end, Douglas would take the prototype and research paid for by the Army and use them to create their new civilian offering, the DC-6. Its overall look was somewhat more sedate than the elegant Connie, but it would still prove a very worthy adversary. Throughout the decade that followed, many modified DC-4s and hundreds of brand new DC-6s and later DC-7s fought it out with numerous generations of ever-improving Constellations. As Lockheed and Douglas tried to capture the imagination and contracts of airlines around the world, they increased the seating capacity, range, and storage of the respective aircraft. With airliners available to take passengers around the globe, the long-range airline business grew in all directions. Luxury travel was augmented by tourist and economy seating. The term coach became common at travel agents and airport check-ins. Lower fares meant higher volume and access to an entirely new market of average middle-class citizens. Douglas continued to provide transports as it had in World War II, while Lockheed created a new early warning radar aircraft, the Warning Star. Over 230 of these advanced electronic surveillance aircraft provided critical support for the Air Force and Navy, especially during the Vietnam conflict. Business was booming for Lockheed and Douglas in both the military and civilian markets, but soon their streak of good fortune would come to an abrupt end. Rival Boeing returned with an unbeatable new aircraft design, which would rattle the foundations of the airliner world, the jet-powered 707. Boeing's president, Bill Allen, had bet the company on this aircraft. The 707's swept wings, potted jet engines, and other advanced technology made the Constellation and DC-6s and 7s seem like antiques from a bygone era. In a brilliant business move, Allen created a militarized version of the 707, the KC-135 tanker, in parallel with the 707, allowing him to save money on research and development and tap into the military and civilian markets simultaneously. In 1957, the same year the 707 took flight, Lockheed unveiled its most advanced constellation, the Stratoliner. It was packed with new advanced features. The Stratoliner's turbo compound engines allowed it to fly non-stop from California to Europe. But the aircraft was costly compared to similar offerings from Douglas. As well, airlines wanted to add jets to their inventories, not only for performance, but for prestige. There was more bad news for Lockheed on the military front. Although the Warning Star would continue to play an important role as an early warning aircraft into the Vietnam War, it was ultimately superseded by the Boeing E-3 Sentry, a radar-equipped version of the 707. Douglas and Lockheed both attempted to wrench the jetliner monopoly from Boeing, but only Douglas was able to crack the market successfully with their DC-8. DC-8s and 707s battled for air supremacy, just as the DC-6s and 7s had competed with the Constellations in the years leading up to the jetliners. In the mid-70s, Lockheed did attempt a comeback in the airliner market with their jet-powered TriStar. 250 aircraft were sold, but it was far below sales targets. Lockheed exited the civilian market once and for all and instead concentrated on military aircraft. Constellations, once the most advanced airliners in the world, were gradually phased out. They were relegated to backup roles, shorter routes, and ultimately served as freighters. Connie, the Queen of the Skies, was a victim of old age and progress and had to abdicate her throne to the jetliner. She aged gracefully, serving smaller airlines up until the 1990s. Civil aviation went through several revolutions since the early trimotors hopped across the U.S. In this time, airlines rose and fell, and aircraft manufacturers pushed technology forward as they battled for their share of the civilian market. Today's network of airlines and aircraft unifying the globe are the end result.